Hello everybody, today's video is called section 10.5. It's called absolute value in open sentences. Absolute value in open sentences really means with inequalities, so let's just call it that. Absolute value with inequalities. Before we start with inequalities, let's go to something basic here about absolute value and equations. We'll start with something very simple. Let's call this example 1. Absolute value of x equals 5. Okay. Well, x could obviously be equal to 5, but the absolute value symbol means that x can also be, or x could have been negative 5, and the absolute value symbol would have turned it into a 5. So the thing about absolute values is if there's a variable inside of it, that leads us to get multiple answers for our solutions. So the answer to this one would be negative 5 and 5. So that applies to inequalities as well. So if we go to example 2 and I make a basic one like x is less than 3, before we start to figure this out, let's kind of think logically now about what x can be. And to make it simpler, let's just use integers instead of every possible number like 1 1/2 and 1 3/4 and stuff like that. So integer wise, x can be 2, it could be 1, it could be 0, it could be negative 1, it could be negative 2, and we have to stop there because it cannot be negative 3 because the absolute value, although negative 3 itself would be less than 3, the absolute value of negative 3 is 3, which is not less than 3. So our boundaries, not including, these aren't included, but our boundaries here, once we talk about every number, including halves and decimals and things like that, our boundaries are negative 3 and 3, but they're not included. So we would graph it like this. Let's put a 0 here, put a 3, put a negative 3. So everything in between negative 3 and 3 would be an answer, and you can just kind of logically put it into there and see if that works. Negative 2, the absolute value, so 2 is less than 3. That's correct. But negative 4, for instance, would not work because 4 is not less than 3. If you'll notice from before, this type of graph is an AND statement from the previous section. I'll put that in quotations. This is an AND statement. So whenever you get something where the absolute value is less than a number, right there, that is an AND statement, and it will be a conjunction. So the boundaries will go on the outside, and you will shade on the inside. Okay. Let's try an inequality facing the other direction. So I'll use the number 3 again, just to show you how similar it is. Absolute value of x is greater than 3 this time. Now let's think of all the things that would work as answers. 4 would be an answer, 5 would be an answer, 6 would be an answer, and so on. We just go on forever. Nothing, 3 would not be an answer, but it would be a boundary, so let's put that in red. 2 would not work, 1 would not work, 0 would not work, negative 1 would not work, negative 2 would not work. Now negative 3, once that absolute value takes hold, now we have 3 is greater than 3. Although that's not true, it is a boundary here, because once we get to negative 3.001 or even smaller, it does start to work. Negative 4 works, negative 5 works, and so on in that direction. Okay, so as you can see, now if we were to graph this, Here's our negative 3. Put our 0 in there. We have a 3. Now the boundaries are still at 3 like they were in the previous example. They're still open circles. Except now we're shading to the outside because everything larger than 3 or everything smaller than negative 3 all fit in to solve that inequality. So like I just mentioned, this is an OR statement. Put a little arrow. So when the absolute value is greater than 3, you're looking at an OR statement. When the absolute value is less than 3, you're looking at an AND statement. For those of you who like to memorize things, you can go ahead and memorize that. For those of you who like to figure things out and just kind of understand them, which I would recommend, if you don't memorize this, you can figure it out just the way I have here. Just start with something simple. Absolute value of x is less than some number, and then think logically about what x could be. And then you'll find that it fits inside as an AND statement, and you shade on the inside of the boundaries. Again, once you do the absolute value of x is greater than some number, you'll find that it is an OR statement because the boundaries are set and you shade to the outside. And naturally, problems are going to get more difficult. So, not too bad though. Once you have that main idea, I think it shouldn't be so bad. So let's come up with an example, such as w plus 2. I don't know what example we're on. We'll call it 4. W plus 2 is less than 3. That's an absolute value. Okay. So again, if you remember with our w is less than 3 example, notice that our boundaries were, x is less than 3, absolute value, our boundaries were negative 3 and 3. Okay, so that number 3, we use the positive boundary and the negative boundary. Same with the one below. That number is 3. We use the positive boundary 3 and the negative boundary of negative 3. So in this case, we can set it up like this. We know that the boundary is going to be negative 3 on this side, and we know it's going to be 3 on this side. And so when we remove the absolute value, it just says, the absolute value is telling us, well, we have two boundaries. So once you put those two boundaries in, we can forget about the absolute value. Okay, so I've replaced the absolute value symbol with this boundary over here on the left side of greater than negative 3, or negative 3 is less than w plus 2. Then once you solve it by subtracting 2 from both sides, or from all three sides in this case, we can graph it. Okay, so we have a negative 5, we got a 0, we got 1, and shade on the inside. So, I'm going to stop the video now and go on to part 2.